In this lesson, we will learn numericals based on gravitational force. We have already learned the equations of motion. The first equation is V equal to U plus AT. Then we learned S equal to UT plus half AT square. And then we learned V square equal to U square plus 2AS. The same equations we can use for gravitation. Like here we have V equal to U plus, it will be GT, because in this case in gravitation the acceleration is acceleration due to gravity, which we denote as G. And the next, when we have the S is a distance, and for a body moving up and down it is a height. So H equal to UT plus half. Now this A, acceleration will be acceleration due to gravity, so it will be GT square. And in the last one we have V square equal to U square plus 2. Now this A will be written as G and the S will be written as height H. So they're basically the same equations, only where there is A, which is acceleration, here we put acceleration due to gravity, that is G, and S is the distance, in this case it is height. There's another thing we need to learn is, if we throw a body upwards, here we know the acceleration has to be taken as negative. So negative minus 9.8 meter per second square. I repeat, the acceleration has to be taken negative because there is a retardation. And the initial velocity U will have some value, but V will be 0 because the body stops. As it goes up, the velocity decreases and ultimately the body will stop before it starts returning back to the earth. So for a body that is a rising body, we need to remember that V equal to 0 meter per second and the acceleration has to be taken negative. Now for a body that is falling down, that is coming downwards under the influence of gravity, here we take the initial velocity U as 0 meter per second. The velocity then increases as it goes down, the velocity keeps increasing and the G will be positive. And before it touches the ground, the final velocity is maximum. So for a falling body, what is 0 here is U. The initial velocity is 0 meter per second and acceleration due to gravity is positive because the velocity keeps increasing as it comes down. To estimate the height of a bridge over a river, a stone is dropped freely in the river from the bridge. The stone takes 2 seconds to touch the water surface in the river. Calculate the height of the bridge from the water level. G is 9.8 meter per second square. To start with, this is a falling body, it's dropped freely. So we have the bridge and the body is dropped. Now when a body is dropped, we know the initial velocity U is 0 meter per second. And in this case the G is given as 9.8 and it will be positive 9.8 because there is acceleration taking place. And the body takes 2 seconds here to reach the ground. So your time equal to 2 seconds. We will use the equation here, S equal to UT plus half AT square. But when we use this equation for falling body, the S becomes H, that's the height. Of course the U is 0 we know, so this is 0 into 2 plus half. Here the A becomes G, T square, 2 square. So H equal to 0 into 2 is 0, half. Now we know the G is positive 9.8, and this is 2 square, which is 4. So h equal to 2 into 9.8. So the height h is 19.6 meter. So this height will give us how high the bridge is from the water, the height of the bridge. So height of bridge equal to 19.6 meter. When a ball is thrown vertically upwards, so this is an object thrown vertically upwards, it goes through a distance of 19.6 meters. Find the initial velocity of the ball and the time taken by it to rise at the highest point. Now this is a ball vertically upwards. So here it's going upwards. If it goes upwards, we know V, the V final velocity is 0 meter per second. The U we do not know, we need to find out. And it moves through a distance of 19.6. Here is given 19.6 the distance. That means the height is 19.6 meter. Now the G here, it's moving upwards, there's retardation, so it will be minus 9.8 meter per second square. So we'll use the equation V square equal to U square plus 2AS. So that becomes V square equal to U square plus 2, the A is G and the S is height. So we have seen that V is 0, so this is 0. U square we do not know, G, so G is minus 9.8, so this is minus 9.8, and here the H we saw is 19.6, so this is 19.6. So 0 equal to V square. Here when we multiply, we'll get minus 2 into 9.8 is 19.6. So 19.6 into 19.6. So U square, we take this 19.6 into 19.6 on the other side, and we get here 19.6 into plus 19.6. So U square is under root of 19.6 square. So U equal to 19.6 meter per second. So initial velocity U will be 19.6 meter per second, which means this object is thrown with a velocity of 19.6 meter per second. It's thrown upwards. A cricket ball is dropped from a height. So this is a falling body. Let's make a note of this. It is dropped from a height, so it's a falling body. Height of 20 meters. Calculate the speed of the ball when it hits the ground and calculate the time it takes to fall through this height. Now we know it's a falling body, so we'll just do, this is a falling body, and for a falling body we know that initial velocity U is meter per second. Then slowly the velocity increases. At this point final velocity is maximum. Here the height through which it falls is given as 20 meters. Here it's 20 meters. And they said the acceleration due to gravity has to be taken as 10. So your G will be 10 meter per second square. And it is positive because it is a falling body, there is acceleration. So in the first part we use equations of motion, and we will use the one V square equal to U square plus 2GS, which means V square equal to U square 2G. We just do this again. So we have V square we know is, we don't know V square. U square is 0 here. So 0, 2, your G is plus, and your H is 20. So V square is here 400. So V will be under root of 400, which is 20. So V is 20 meter per second. For the next part we have to find the time. So for this we'll do V equal to U plus GT. We know V is 20, we just found that out. This is 20. The initial velocity is 0, like here we have written initial velocity is 0. We know G is plus 10, the falling body. T we do not know, time we do not know. So we have 20 equal to 10t. So t equal to 20 over 10, and your t equal to 2 seconds. So it will fall, it will take 2 seconds to reach the ground. A ball is thrown up with a speed of 15 meters per second. How high will it go before it begins to fall? So here we have a ball which is thrown upwards. So this is upwards. If it's thrown upwards, which means V, final velocity, will be 0 meter per second. And they said it is thrown with a speed of 15 meter per second. So initial velocity is 15 meter per second. Now this body is moving upwards, and as it is moving upwards, the acceleration will be negative because there will be a retardation. So G will be negative. Here we use the equation. In the sum we will use V square equal to U square plus 2GS. It is the same as 2AS, but we know that for a body is rising up, the A becomes G, the S becomes H. So we have 0 equal to 15 square to rising body minus 9.8. The height is, we do not know. So 0 equal to 15 square is 225, and this will be minus 19.6 H. I take 19.6 on the other side, so 19.6 H, the minus becomes plus, it becomes 225. So H is 225 over 19.6. You calculate this, you get 11.4 meter. A piece of stone is thrown vertically upwards. It reaches the maximum height in 3 seconds. If the acceleration of the stone is 9.8 meter per second square directed towards the ground, calculate the initial velocity of the stone with which it is thrown. So here is an object that is thrown upwards. So this is a rising object. Now for a rising object, we know V, the final velocity is 0. So 0 meter per second. There is a retardation, so the acceleration due to gravity is to be taken as minus 9.8 meter per second square, because the velocity decreases on the body as we move up, and the time here is given as 3 seconds. So for this sum we use the equation V equal to U plus AT. Now we know V is 0, the final velocity. The U we need to find. The A is the acceleration due to gravity, and the time is given as 3. So this is U, and now we are going to take minus 9.8 because it is retardation. This body is retarding, which means the speed is slowing down. For a rising body, the speed is slowing down. It goes slowly, it stops, and then it returns. So 0 equal to U minus 29.4. So we have 29.4 meter per second equal to U. So initial velocity, the body is thrown with a velocity, initial velocity is 29.4 meter per second. A stone falls from a building and reaches the ground in 2.5 seconds later. How high is the building? So here is a falling body. It is a falling body, which means its initial velocity will be 0. Then the velocity keeps increasing. Here the final velocity will be maximum. The acceleration due to gravity will be plus 9.8 because this body is accelerating, the speed is increasing as it falls down. And the time given to us is 2.5 seconds. So here we will use the formula S equal to UT plus half AT square. So the S is the height, u we know is 0, initial velocity here is 0, time is 2.5, half. The acceleration due to gravity, the a will be now is taken as g, and that would be 9.8 t square 2.5 square. So h equal to 0 plus half 9.8 into 2.5 into 2.5. So h equal to half 9.8, and this will be 6.25. If you do this calculation, your x comes as 30.625 meter. So that is the height of the building. So the height of the building here is 30.625 meters. A stone is dropped from a height of 20 meters. How long will it take to reach the ground, and what will be its speed when it hits the ground? So here we have a falling body. This is a falling body. Now for a falling body, we know the initial velocity is 0, then the velocity keeps increasing, and just before hitting the ground, the velocity is maximum. The acceleration due to gravity has to be taken positive because the velocity keeps increasing as it drops down. And the height here, this distance traveled will be 20 meters. So in the first, to find the first, we'll use the equation s equal to ut plus half at square. And for that we know the s we replace by h because it is a height, and the a we replace by g. I will use a formula. We know the h is 20, so we put 20 equal to u is 0, so 0, and time is not given, plus half, your g is 9.8 and t square. So 20 equal to half into this is given as 10. Acceleration due to gravity is given as 10. So here we cancel half and 10, and we'll get 5 t square. So t square is 20 over 5. So your t square will be 4. So t will be under root of 4, and your time will be 2 seconds. So you take 2 seconds to reach the ground. For the next part, for the second part, we have to find its final velocity. So we do v equal to u plus at. V is the final. U we know is 0. So we have 0. We know the a is 10. So we just got to change this. This is 10. They've asked us to take it as 10 meter per second square. And the time here is we have calculated as 2. So we have v equal to 10 into 2. So v equal to 20 meter per second. So it will drop, when it drops, its velocity will be 20 meter per second. So velocity will increase from 0 meter per second as it goes down to 20 meter per second. When a cricket ball is thrown vertically upwards, it reaches a maximum height of 5 meters. What was the initial speed of the ball, and how much time will it be taken by the ball to reach the highest point? Now in this case, the g is to be taken as 10 meter per second square. Now this is again a rising body. So we will, here it's a rising body, which means v, the final velocity is 0 meter per second, the h is 5 meter, and the g is the rising body, so minus 10 meter per second square. So here we use the equation v square equal to u square plus 2gh. We know v is 0, so 0 square, u we do not know, 2g minus 10h is 5. So 0 equal to v square minus 100. So 100 equal to u square, u will be under root of 100, so u will be 10 meter per second. So that means it is thrown up with a speed of 10 meters per second. Now in the next we have to find how much of time is taken. So we will do v equal to u plus gt. We know final velocity is 0, u we have calculated as 10, so we put 10. We know the g here is minus 10 and the time we need to find out. So 0 equal to 10 minus 10t, we take it on this side, 10t equal to 10, so t equal to 10 by 10, so t equal to 1 second. So it will reach its highest point in 1 second.